Good morning, everyone. How are y'all doing? Happy Tuesday. Let me get the music down a little bit so I can hear myself think as well. Cool, awesome. Well, good morning, you two. I see that you're on the stream already. I'm glad to have you here. Having a coffee myself here, enjoying the Tuesday morning, the relaxation that it comes with as well. Monday was a pretty busy day already, but Tuesday is my favorite day nowadays because I get to stream and hang out with you guys, which is going to be fun. This week is actually pretty busy for me. I'm speaking at an event in Springfield, Missouri tomorrow evening on AML.net. One of my favorite talks, giving an introduction to machine learning in .NET for a couple of people. That's something that I really enjoy doing because there's always that initial experience with AML.net like to do, and I see their kind of excitement in their eyes when they discover what you can do with this library and all the cool things you can do. So it should be really fun. But as always, we have to continue working on our library, right? We have to continue working on AMLOps.net, and it's been really fun lately. I feel like we get more and more traction. People are contributing. There are questions being asked. You can see that some people actually use .NET and AML.net in their organizations. More and more kind of turn their eyes to this library and potentially want to use it as well in their applications. So that's really exciting. It's always fun, especially if we can get someone that has industry experience with creating these models and give some feedback on how they want to use it, right? It's the best kind of thing. Well, I mean, before we get started though, how are everyone doing? Who do you have on the stream right now? Where in the world are you? What do you expect from this stream this morning? Anything in particular? If not, and if you're shy, that's completely fine. But please use the chat during the stream today. It's always fun to kind of hang out with you and catch up with you and see what you're doing. Cool, awesome. Well, for those who couldn't join on Sunday evening, we had a really good session on road mapping. I really thank you all who joined into that session. We came up with some really good ideas and some thoughts, and the final product can be found here on the repo page here, right? So it's a couple of things here that we kind of jotted down, and the green ones are things we already implemented, and the yellow ones are things that we want to pursue and explore. That's great. I'm glad you're enjoying the roadmap there. So things that we've already done, and can be hard to see. Maybe I'll zoom in a bit here. Hope that's better. Our hyperparameters, right? AJ added support for that before. We have added metrics and confusion matrix support for evaluations, and so forth. We can upload and download models from the repository. Kind of basic stuff, but still useful. And we have to continue evolving, and as you can see, there are things that we've added in the middle here, but we have very little at the ends of the spectrum. Hey Brett, good to have you on the stream today again. Hopefully it's been useful, and I enjoyed the conversation I had with you. Hope things are going well. So we can see here at least that we have nothing on the data side yet, so we need to manage our data. As part of our MLOps workflow, we need to understand what data was used for a model, how it was trained, and have some kind of traction on that as well. And the same thing as well on the deployment side of things, we want to understand how we can deploy and use a model in production. I'm all good, thanks Brent for asking. So you see that we have to kind of add things to the skeleton right now. We have started doing things in the middle because that's easy for us, but we've not yet done things in the end here. So deployment is going to be interesting because we want to deploy as containers or serve it as a file. We need a client and an API to interact with everything we do here, and we also need some automation hooks here for integration. Maybe a global tool, .NET global tool for the CLI. Definitely we need API integrations here. Mitchell on Sunday's stream, he suggested InfluxDB to push things to, and that's a really interesting thought. I have to look into that more. But what I want to do today is to start at the top of the pyramid here on something we have not spent enough time on, and that is our data management side. And things we have here are has the data changed? Send one model. So let's say we train a model multiple times, And the first time we get a great result, and the second time we don't get a good result, maybe like 2 months later. To understand what has changed, it's always important to understand the data. Like, has the distribution changed of the data? Has the dimensions changed? Has the schema changed? Has it changed overall? Maybe with a hash. So there's multiple things we have to explore here. And today what I want to do is start exploring one of them and see how feasible it is and how it kind of fit into the overall scheme of things. Sounds good? Hopefully. So we added quite a few new features here, new issues. So if you want to look at them, you can. I spent some time yesterday evening to add them here. So we have some data issues here related to what we're looking at today. We also have some deployment issues here that is related to deployment on the other side. And I haven't had a chance to add all of the things we want from roadmap up here, but we definitely want to go and add them here. But as always, there are plenty up for grabs here. There are a couple labeled as first good issues here. I can try to add some more as well later for things that are good starting issues. Alright, but I think what I want to do today is do this. I want to add ability to capture data dimensions for us, to understand like how many columns we have, what kind of rows do we have, maybe even capture the schema itself of the data to understand how that's changed over time. And I think the best way of understanding that is to look at an example here, first of all, for ML.NET in general. So this is a review predictor that we've created before, and we've seen it multiple times during the streams. And what it does is that it trains a machine learning model to predict if a review is positive or not. So sentiment analysis, binary classification, it's like a hello world example in many ways of machine learning. But it's perfect because it allows us to fit MLOps.NET around that training and understand how we would use our MLOps library in that sense. And we can see here we're creating our ML Lifecycle Manager and do things here as well. And this, with this library right here, it's actually an old NuGet package, so we need to update this review predictor, but it still allows us to understand some of the things going on here. So for our purposes here, if I remove some of this MLOps code here, just to make it a little bit easier to see, we have our ML context as always in ML.NET, and we are loading our data from a text file in this case. It's going to be a comma separated file and has headers. And that's all good. And it ends up in a data view. And the data view is lazy loaded, as everything is before we do the fit method right here, right? So everything before here goes super fast because it's just chaining methods and like virtual pointers to heap. And in the fit method, we actually execute all of those things, load the data into memory, you know, do all the stuff here. But if we want to track data, dimensions and schema and so forth, we can almost assume that we have all that information on our data view. And to kind of have a look at that, let's kind of dive into the data view and see what kind of methods we have and things here. So we can see, for example, that we have schema, of course, right here, but we also have get row count here. So get row count would allow us to get the number of rows in a data set, which we definitely want to store. And we also have the schema, which probably allows us to get all the columns, so the names, the numbers, and the types. So let's go into schema here to see here. Let's type data view schema, and it's a enumerator of lots of columns here. Okay, so basically we have to get the enumerator, I guess, and loop over all the columns. And a column here has a name. So that could be, for example, in our review predictor case, it could be like the review, for example. And the data type here could be maybe string. I'm pretty sure they use internal types here. Data view type. I've seen this before one time, and it's like an enumeration, I think, of types. Oh, maybe it's a normal type, raw type. That's actually nice if you could do that. So let's do raw type instead, because that's going to be easier for us to handle. But they also have a key type, I think, that it's a little bit detached, which is nice. Alright, so we probably want to do today is we want to be able to more or less say, I'm just going to write this in theory, it would be like mlops context track data or something like that, and we will pass in the schema like this. I think that's something kind of makes sense to me, at least. It's like we would have track data or log data. I'm not sure what you want to call the name or the method, but log data or track data, passing the data view itself, and not the schema, but this is data view, and it will catch the schema from there, and it would capture the raw counts as well from there, and we will store that in our metadata store, and I think that would be a good way going forward. Okay, I talked a lot here. Sorry for making your ears bleed, but I'll have a sip of coffee and I'll let you add your thoughts here. Does that sound reasonable to you guys? Is that a good structure? Would you like to interact with the library in this way? And do you think this is a good platform to build on? And actually, we would have to create a new catalog here, so it'd be data like this, log data. Cool. Hey John, good to have you on the stream as well today. Wow, we get like celebrities on the stream right now. It's pretty awesome. So Brett, since you're new to the .NET world here, you should follow John Wood on YouTube, or in general. But he has some awesome videos on ML.NET. I'm sure you already found them on YouTube, honestly, if you're looking at ML.NET. And he has some really good videos on things that are formatted well and make sense. Not like me, doing live things that doesn't make any sense. Alright, enough of that. So, let's do this, right? So we have our solution here. Source test, same as always, right? Nothing special. Well, editing is what makes it worth it, right? So, what we need to do here is a couple of things here. First of all, let's look at the general structure of the context here. Log data. Cool. Let's call it log data. That makes sense, Brett, because we call a lot of things log here. We call a lot of things log metrics and that stuff like that, so it kind of fits into the paradigm. So, briefly here to look at the structure. An mlop context is what you build when you want to use this library, so you understand like where it's connected to, and we have like a storage for our data associated with a model, and we have a storage for our models, so like a model repository that holds the actual zip files. And that's all good. And the way we split this up is that we have different catalogs that maps to, not completely maps, but slightly maps to the catalogs in ML.NET. So we have like an evaluation catalog that holds methods for logging metrics, so the accuracy, those kind of things. And we have, go away. We also have like catalog for models here, so we can log models, and you know, this one is going to have methods for upload model and download model, kind of standard stuff. And we have also trading and logging hyperparameter stuff. And we have a general lifecycle catalog. It's a bad name, but it's for like managing runs and experiments. But you can see already here we have no place for the data, and that's the first thing we have to do. We have to add a new catalog for data management. We haven't added that yet, and that's good. So that's going to be really quick to add. We can just use one of these here. So we'll add a new catalog here for data. This is going to be an entry point for all this stuff here. And we can call it data catalog. I'm trying to not spill my coffee on me if you're wondering why I'm so careful here right now. I have it just in front of the keyboard, and I have the microphone. And I promise you I will spill it at some point during the stream, and that will be a good laugh for y'all. Alright, so we have our internal sealed data catalog, and actually it needs to be public because it's going to be used by our end users. That's all good. And I'm looking at the template here because I want to make sure we have something similar. So user 2, it's actually a good question. I usually normally don't use catalogs for things I do in my like client work. But the reason why I use catalogs here is because it's a nice separation of concern for different actions. And it's the way ML.NET does things as well. So for example, if we look back at the review predictor here, and look at the ML context here, and I'll go into the ML context. The ML context is like, this is the actual Microsoft ML, catalog itself. But you can see here, this is how they have decided to structure their library, where we have a catalog for different kinds of ML tasks here. So they have a binary classification catalog, and they also have like a model operations catalog, which is like the model, and this is where all the methods for model management is, and data stuff as well. So what we're trying to do here is just make it familiar to people using this library, and that's something that's good. Ranking videos, okay. I have not done anything with ranking, by the way. I really need to get into that. So I'm gonna have to look at John's video as well on ranking. Alright, so that's kind of the idea. We just want to make people feel at home. Alright, so let me move some stuff here because this is taking too much of my focus. So let's create a constructor here, right? For data catalog. And the data catalog is going to take an I metadata store, because that's kind of where we're going to store things. We're not going to have any need to have a dependency to our model repository. Okay? So that's the first thing here. Second thing, since we have made sure that we treat warnings as errors, we need to also have comments, XML comments here for our things, so people can understand that through IntelliSense. And we will call this operations related to logging data, or I'll call it tracking actually in this case here, tracking the data used to train model. Okay, it's all good. I'm just gonna call this CTOR, stupid. Okay, so that's perfect. We have some kind of initial structure here, and we can then put that in our MLS context here. And we'll put that first, more or less. Actually, put it after life cycle. That's where it makes sense. And we'll create a data catalog here, data. Add a comment here, and what we'll do here is we'll inherit docs from the interface here, and then we'll add an interface member for the data. Cool, that's awesome, Brett. Wow. You're asking for permission to use MLOps.net in your company, and MLOps.net is in a beta state. But that's great. That's cool that you're using AWS actually, by the way. So AJ added support for S3 buckets for model repository, so you can use that. And we still have to add support for DynamoDB for the metadata, but that should be like a quick one we can do during stream if that's something that you need for your company, by the way. So that's a super simple one, or you can actually do it yourself, honestly. And I can help you guide you through it. That'd be really fun. The structure is already there, so it would just be implementing the calls. But that's great. Super excited about that. Alright, so to tracking the data used to train a model. Alright, so we have the entry point set here. That's really good stuff. And that looks good, that looks good. And now we just need to make sure we initialize that here. We'll say data, and that will be a new data. And since this is a library that is consumed, we don't have DI unfortunately, so we have to make these things ourselves like this. It's not great. I actually want to look to see if there's a DI framework for NuGet packages like this, but I don't think there is one, so that is okay. Where did my music go? There we go. And the music you listen to is, as always, Carl Franklin, and it's music to code by, which is supposed to be good for your alpha waves. Alright, so what we need to do here, let's get back into this now. So let's create a method here for the things we want to do. So we can envision at least that we need to do something like this, and Brett, you want to call it log data, right? So public void log data, and we're going to do something here to log the data. And we decided that we wanted to take an data view here. So we're going to rely on the ML library here because we don't want to use too much reflection to figure things out here. So that's good. We're passing in a log, an data view here, and It may be async, it may be not. We have to look at the underlying structure here later to see if we want to be async or not, but right now we're just going to make it synchronous. Alright, and eventually what we're going to do is going to call the metadata store here log data and pass in the data view, I'm pretty sure. That's going to be kind of the idea at least here, right? And I don't think we need to return anything. It's going to be a void method. We just want to structure the data here. Let me think here. Do we want to do any massaging here? Or not? It's possible that we want to do some massaging here. Let's see how we've done it before. So previously we have kind of decided that this is where the buck stops, more or less. We don't have dependency on m.net in our lower layers, but we only have it in our upper layers. So for example, here when we pass in the confusion matrix here, we actually create a new one, our own implementation here, and use that instead of the m.net confusion matrix here. So that's fine. So I think before we do anything else, let's go down to the lower levels and understand how we want to structure this and how we want to save this. And then we'll go back to figuring out how we want to do this. I'm sorry, I see these things, I need to remove them. Alright, so let's take one example to start with here, SQLite. That's going to be the easiest one to use here. So storage, SQLite metadata store. We need to add a method here for, actually let's do that to the interface later. But in here, we're going to start adding public void log metric, sorry. Let me actually do it to the SQL Server first, because that allows me to do some more unit tests as well. Because we have a better structure there. And there's a good issue for anyone who wants to fix that as well. Alright. So we'll do that here, public void log data, right? And we'll see what it takes right now. I'm going to keep that open. But in any case, what we want to do here at least is open a DB context, and we're passing in a factory to do that here, so we don't have to rely on it completely. And this is when it gets interesting. So now we want to log it. So we need an entity for it, right? Some kind of entity. And that is going to be interesting. And the way we've done it before is we create interfaces for entities here, and we implement them in each storage provider. So we can have like NoSQL implementations and SQL implementations and something else if you wanted to. But we need to add a new one here, and it needs to be called, I'm thinking that we can either call it data, and so the things we want to, let's just give the name for now, and we can rename it just afterwards. But I want to kind of give you an idea what I want to store here first. So it probably makes sense to have two different storage things for this actually. Yeah, data tracking is a good one. The reason why I'm thinking about it, so let me look at the things we want to store here are two things. And it may make sense to keep it in different interfaces. But like one of the things it's going to store is row count, right? We want to be able to have number of rows in data. And then we also want a schema. And I'm wondering if that makes sense to store a different place or somewhere else. Because we want something like a schema. I'm not sure what it's going to be for type here. Just do like that for now. So that's going to be kind of what I want to store. The schema, on the other hand, it's going to be just number of columns here and rows. So, and one thing we definitely want to store here as well is the run ID, because we have to associate the data with a run ID. That's going to be fine. We also want a GUID here for ID. So, and I think this is all good. The one I'm more concerned about how we want to structure this is the schema here. The schema is going to contain just a collection of columns. And I feel like we should actually have a different one here for that. We should have a column entity instead. And that one can point back to the data instead. And that one can have everything we need. I think that makes more sense, right? So we can call that. We can also Sorry if I'm quiet here, I'm trying to think here. The reason why I'm thinking is because we have multiple issues going forward as well that may build on this. One of them is going to be location of the data, for example, and that has nothing to do with schema. So it may make sense to have multiple entities here. Maybe we can have one that's called iData tracking, and that's going to contain some things. iSchema, let's call it data schema, and another one called column or something like that. iData column. So we're gonna have a reference to the data columns from the data schema, and the data schema can have columns, I guess. I wonder if we're also gonna have row count here or not. Does it make sense to have the row count on the schema? That's, I guess, my $1 million question right now. Because eventually what we'll add as well is distributions. And let's do this. Let's have a data tracking one for the general stuff. This is going to point to data schema, and this can then later point to other stuff as well. And this one can hold the rows here. See, this is what I do when I don't prepare for a stream. I have to think about it, which is the idea of live streaming. Alright, so this is what we're going to do. We're going to have a data tracking one here. iData tracking. Or let's call it iData actually, because it's kind of what it is. And then what we'll do here is add another interface here for an entity. This is going to be iData schema. And then we'll add another one here for iData column. Data column. I hope you're still following here. So iData is going to have an ID and a run ID, because that's kind of what it's going to be. And it's going to have a row count. But then it's going to have, since we're going to support like flat entities, I'm going to remove this and it's going to be just this. And iData schema is going to have a GUID for data ID, and this is going to have GUID for ID, and then iData column is going to have a GUID for ID, and then we're going to have the fun stuff here. This is kind of what we want to store. So we want to have name. This is going to be column name, right? And type. Let's call it string for now, type here. And the schema here is going to have a strong property here as well for number of columns. I think that makes sense. Let's call it on column count here. And I'm going to move this one to schema, although it doesn't make full sense to be there, but I feel like that's kind of where it's supposed to be. So I'd rather have it here instead, because then we can have like column count and row count together. That'll be simpler. All right. Do you completely disagree on this structure? It's a little bit weird, I understand, but I think it's going to be easiest. Okay. Oh, is that why? Sorry. Public is an interface. Do we need this then? Yes, we need that. Okay. Data associated run ID. Data schema dimensions. Okay. So are you thinking that this one should be iData schema dimensions, the iData, or you think the iData schema should be that? Or do you want a completely separate class for that as well, or entity? Let's see. Okay, so that could be, I guess, that. The only thing is that the iData column is pointing back on an iData schema. So I feel like the iData schema is more general on the purpose we're trying to do. So I think let's keep it as an iData schema right now, but let's definitely, if you want to rename it, we can definitely open an issue about that and discuss that on an issue. Because that's, I mean, I'm up for that for sure. We'll definitely point columns right now, so it kind of makes sense, I think, for this. Reference to data. To data. Okay, let's clean this up real quick here. I know a lot of time right now is spent on just the structure here, but it's important that we think of this. If we get this right, it's going to be a lot easier to implement this. And, you know, we're also trying to just make it as simple as possible here for ourselves. We don't want to spend too much time designing stuff, but it needs to be extendable, I guess. All right, final interface to fix here before we get this working. Yeah, well, it's still an open source solution that we have fun with, but I'm really happy that there's getting some traction and someone wants to use it for sure. And we want to make sure it's, I want to make sure it's like you can build on it, and I also want to make sure it's developer friendly. Like user 2, if you want to contribute or someone else want to contribute, I want to make sure it's fun to contribute to and it's easy to understand. That's kind of why I'm doing this on the stream, because this is kind of where I collaborate and discuss ideas, make sure people agree, because I don't really want to do anything in a vacuum when no one is going to contribute to it or find it useful. It's kind of pointless. Data column. Okay, that is fun. ID of the column, name of the column. Cool. Any level can definitely contribute. You don't feel like you're a novice. I'm happy to have anyone contribute, and I'm happy to kind of guide you as well. We have some more easier issues as well that you can get started with. So type. That just should take like half an hour at most, but totally fine. Okay, so we have those simple things, and we can definitely add more stuff here later, but now we have at least the schema in general, so that's really good stuff. Okay, got that. Okay, so now we have to implement the actual entities here, and we'll do it in SQL Server first and see how it goes. Yeah. Compliance is always hard in anything, especially machine learning. You should definitely look into fairness and bias tools, Brett, as well. There's a couple of those that you probably want to look at when you talk about you know, compliance and legal. It depends on, I guess, what kind of industry you're working in, but most of the time you need some indication of if the data is not biased, you're not putting any bias into your decisions and those kind of stuff. And Amazon has that built in as well, so it's not very, very difficult, just another domain to look into. Alright, so now we have the decision of creating our structure here, either here or later. I feel like we should just pass in the schema here. Actually, let's do this. Log data. We can either split it up into multiple methods, so one can log the data itself, another one can log the schema columns, and a third one could log something else. Given that this is going to be agnostic in that lifecycle catalog for storage provider, we can't necessarily create the entities there. We have to create them at our own level. So I think that means we have to pass in the schema here, and I'm okay with that actually. So that will force us to create a dependency on ml.net here, but we already have it in the library, so it's not the whole world. And I feel like this is something we need to do. Alright, so we have to do three things here. we have to create, and I'm going to remove the comments later, but let's just think about it. We have to create iData. We have to create iData schema. We have to also create iData columns list, right? Those are things we want to do here, get this working. So to do that, first go ahead and add entities for these in here. And we definitely won't finish this one today, I think, but that's okay. So we need an entity specific for SQL Server here, and we're going to call this iData, and we're going to call this public internal sealed class, I think. Can we do that? Yep, good. We're going to implement this interface here. I don't want to unseal it. Oh, that's why. Sorry. And that implement interface. Sorry. Implement simplicity. Oh, annoying. All right. In our case, it's going to be a public property here. It's going to be a GUID. It's going to be ID. And we'll have run ID as well. Okay. That satisfies all of those conditions. So if you look at this, we don't have anything else here. And okay. Sounds good. We'll then create I'm trying to think of this, how to make it simple, but yeah, I think this I have to do. Just do this. Data schema. I'm mostly surprised that this specific issue here is actually bigger than I thought it was. So that's I'm kind of taken aback by the fact that it was more work actually than I thought. Do we call that schema? Apparently we call it something else because it does not want to find it in our interfaces here. iData schema. I think we have to make them public first of all, because they will be used. There we go. That's going to definitely fix it. Okay. All right. Can we get something? Okay. I don't like how it's like throw not implemented exception, but I don't care about that. But I'm just going to use this as a template here to make it a bit faster. Like I feel like it would be much better if they could just give me the properties instead. Ah, this is pointless. Prop GUID ID done. Prop GUID data ID. Int column count row count. So some fun things here though is that since we're using Entity Framework core here, we can make some useful stuff here instead. So we don't need to load things to the city. So this one here is going to have a data schema, right? It's going to be a virtual data schema. So we don't have to populate that ourselves. Just like that. And why is that? I can't have sealed if I had that. Interesting. Okay. I guess yeah, you can't have virtual methods in a sealed class. Okay. That is fine. So that will be our data schema. And did we do that somewhere else, by the way? Runs. I see. Okay, so we didn't do the mapped. That makes sense. So we'll skip that actually right now, but we'll populate that later Just as the decision we made before. I'll do that not map right now. We made some decisions that I don't want to backtrack on here, of keeping this flat, and we're gonna keep those for now. Data schema is fine, and then finally iData column here. Okay, I think we'll be able to at least finish the SQL Server implementation today. I don't see an issue with that. Okay. Looks good. Get this one. Okay, that's better at least. Now we won't have the interface name. Okay, so name, ID, string, those kind of stuff. Perfect. That should be a last entity, and now we should be able to build them. And if I don't have any other issues here, set. Let's see, this is going to be an internal sealed class. We'll skip that. Okay, perfect. We do have the need to have the, I think it's called, okay, we don't have that yet here, but we do need that as well here. So we need another one here, GUID for what's called data schema ID. Otherwise we don't have any reference back to that. Okay. The data schema. Perfect. Let's go back and add that, and then I think we are done with the entities and can start implementing this from scratch. And I thought I added that to public. Okay, good. We are good. We're good. And this one is going to be then the data schema is going to have a list of columns here. So we're going to have a list of data column. And we'll call this not mapped. All right. Perfect. That's good. Okay, so to get this working now when we have this set up properly, what we need to do here is first of all add these to the context. So we'll go ahead and do that real quick here. That's going to be data. And now we can start building on top of this, which is good. And we'll add data schema to the context. And finally we'll add data column. Okay. Perfect. So we have that in our Enter Framework core context. We have our data view coming in. We are good to get started here. So first of all, we need to create our data entity here, just like we do above here in this context. So there'll be new data, and that will be, we have to set some things here properly. So we need a constructor just to do some things here for us. And ID is going to be just a new GUID, but just do that for now. We can of course set the ID, let the database set that, but I think what we decided to do so far is by just doing this, because we have another like NoSQL approach where we have to set this, and this is just the easiest way of doing it right now. But that should be a new issue, honestly, to refactor the SQL Server thing to just set this as, as a key instead, and let that be automatically incremented. So this is a little bit unnecessary, but for now it's okay. and we'll pass in the run ID here and set that here directly. Okay. So this will allow us just to do do this, but we need to pass in the run ID here as well. So run ID is going to be the association here between things. So data schema is going to be then a new data schema, and what we'll do here is also create a constructor to take in some stuff here. That's going to be the data ID, and honestly what we can do here is pass in the data, but that should be fine. Data ID, ID GUID. Okay. We definitely need to improve this because this is way too verbose. But let's kind of work through this a little bit first and see how we could refactor this later, because this is way too verbose for me. Okay, so the data schema here, we can directly set some stuff here on this one. Like the row count here is going to be data view get row count, right? And the column count here is going to be data view schema, maybe schema count. I think count is going to be counting the number of columns. Okay, we have a long instead of an int. Okay, so let's change this one here to a long. That is fine. It seems to be nullable as well, but that's something we can fix later. I doubt that we will actually have something else here. Get row count, get value. And we'll just make it 0 if it doesn't exist. Okay. Perfect. Okay. Does that look good so far? Have you all fallen asleep? Hopefully not. There's a lot of boilerplate code here, honestly, but it's necessary. Alright, so we have the data schema here, so now we need to just loop over all the columns here to track those. And we can do that by doing data schema, well, you're kind, Brett. I'm not sure if it looks reasonable. It looks like something at least. Okay, data view, schema. So schema is going to contain, it's going to be enumerable here of columns here. That's kind of how the schema is set up if you looked at it before. So each time we enumerate over this one, we can have a column, which is good. So now for each of these, we need to store and create one here. So data column is going to be created, and it's going to be a new data column. And if we look at what we are having here, data column, we have name and type and data schema ID to pass in here. So we'll need a constructor as well here. And this one is going to take at least the data schema ID to associate with. Just like another time here, we'll do new GUID. And the data schema ID here is going to be data schema ID. Okay, so we'll do that real quick here. That'll be data schema. Okay, like that. And now comes the fun part here. Now we're actually going to track the columns here and what we have. So we have the name, right? And that will be column, not columns, plural. Column dot name, and type. It's going to be column type and raw type, I think, and then full name. let's call it, see if name maybe makes it a little bit cleaner at least. Okay, so that's perfect. So now what we can do is each time we loop over this, we'll go ahead and say, okay, db data columns, add data column. Okay, and here we'll do is db data add data, db data add data schema, and that needs to go into data schema. So let's think about this a little bit here, because finally what we're going to do here is just do a save. When we're done. So that's going to be a log data async because of that. And this is going to be an async task. So let's think about this a bit. Is this reasonable? What do I feel about this? Can we build on this later? We can definitely add things to data later, which is going to be location and stuff like that. So that makes sense to keep. We'll need that. Is there a chance that we already have a data entity? Probably, because if we add something in the future where we'll go ahead and add location, it's possible that we already have a data. So I want to make sure we check for that quickly. Actually, we can do that later in a future story. I think this is good for now. So what we need to do now is add this to the interface, add not implemented everywhere else, just to test this, add some integration tests in SQL Server, and see if we get this working as expected. And then we'll take it from there, I think. So here we need to add a method log data sync, data view, logs the data. Okay, can't have a sync in interface. Perfect. And we'll go back to the catalog here for the data that we created before, and we'll see how we have a method called log data async now. Pass that in. It's going to force this one to be async as well because the save changes as async. And that will end up with something like this. Something like this. And what is wrong here? Oh wait, sorry. Okay. Missing XML comments. Logs the data used to train. Logs the schema, column, and row count of the data. Perfect. All right, nice. So if you build this now, it's going to start failing because we haven't implemented the iMetadata interface everywhere. Let's you go ahead and do that real quick with not implemented. Add some integration tests and make sure this works. That's going to be the next thing here. So we have two storage providers as well for this that we haven't done yet, and we'll get to them later, but not right now. One of them is a SQL Server, and that one we should have got to. So why is that not working? Log data async. Something with the signature is off here. Public data async. Oh, okay, sorry. Run ID needs to add as well here. That's why. Okay. And that's going to complain missing XML comment here. And go back to the data column. Data catalog. Perfect. Go ahead and add that here as well. Pass that in. Run ID. GUID. The best thing I think is that we have treat warnings as errors, because we don't miss any of these like small cleanup stuff that we need, but so easily you can forget if you don't treat warnings as errors. So that's good. Okay, all right, so now we have some of those issues. That's perfect. So we're gonna just implement this and throw not implement exception wherever you went. Okay, so here's this one. I'll move it to the end. We'll get to that one later. And then we have this one, storage account, which is going to be a bit different. Where did you go? We don't need all these, by the way. Let's remove these. This is just noise. Where? Okay, perfect. At the end, where I want it. Let me just clean this up. Okay, and then finally, I think there's one more issue here. ML ops context. Okay, so we need to implement here. Okay, that makes sense. So we need to add some more stuff here. If we look at the context here, we need to add those things so we can fetch them. In our case, it's all of these. Okay, put them there. We should build now, I think. Nope. What is going on? I thought we had implemented them. Oh, public. Jesus. Too early in the day to get this working, apparently. Yeah, you caught it, Brett. Good catch. Alright, so now it's going to be fun. So what we're going to do now we see it's building, everything's fine. So now it's going to be fun, because now we're going to run integration test against Docker container running SQL Server. And this is something I really enjoy doing, so let's do that. And the first thing we have to do here is open, I'm just going to open Visual Studio Code, because I can manage my container here and kick it off. And we'll see how that works first. So I have my Docker containers right here. And the way we do integration tests in this project is that we kick off a container running SQL Server in it, and we can then hit that one locally to try different things. You can see I've already installed SQL Server anyway, but this is the way it's going to be done in our CI/CD pipeline, so I want to make sure we do that. And I think it is this one right here, so we'll start that one. But we need to start it with some parameters. It's the Azure one. Okay, so this is the way it started. Docker run, we accept this one. It's going to be just a simple password that's local, and ports are mapped here. And this instruction is in the wiki as well for the repo. So if you want to do this locally, you can actually go to repo, go to the wiki, and I added the little instruction here on how you do it here. So you can run these locally. It explains how you install Docker Desktop, and explains on what image to pull down and like how to configure this. So if you want to do it yourself at home, feel free to do so. That's completely possible. But yep, all right, so we're gonna start this, and it's gonna kick it off right here. And that, if you wait just a little bit, we should be able to run just the basic integration tests here that we have to make sure that the container is up and running. And they'll show up here, and we'll see we have the SQL Server integration tests here that currently do a couple of things here. For example, we have some experiment creation here. So let's go ahead and run these and see if they pass, just to like a sanity check before we start writing tests ourselves here. Okay, so our container is functioning as expected here. Perfect. So let's get back to it. So here's the integration test we have running right now, and what we're going to do here is add additional ones for our specific scenario. So what we'll do is add a test method here. Actually, we can just copy paste whatever is above here and modify it for our purposes. So what we want to do here is say log data async given valid data view should log data. Really bad name, sorry. But that's gonna be what we're gonna do here. In our case here, the method we want to execute here is going to be log data sync, and what we need here is we need to run an experiment here, and we already have that set up in our range method. And the thing we need now is the data itself here. So we need a way to load data. So like what we need to do here is load data and then pass that in using ML.net. So let's see how we do that. I feel like we've had some similar issues somewhere else. That's why I'm going to try to find that. I feel like we've done something with data somewhere else here. This is the configuration piece. It's all good. Okay, so we have something here. Perfect. So this is the way we upload models in general. For our purposes, what we can do here is just make it simple here. Add a data catalog here. So we'll add a new folder here. Call this data, and we'll go ahead and add data here. And I think I have some data already, so we'll add an existing item here, and we'll navigate to the data and find it. I think I have it under Git. We'll just use the review predictor data for now, because that's going to be a good test. And let's see, where's the data? Wow, don't I have the data somewhere? I should have the data somewhere here. I'm a little bit oh, it's probably, I know why. All files. We should have it here then. Product reviews, perfect. Alright, so we have that. Let's copy it over always, like we always do here, to make sure it goes into the bin folder, so the framework can find it. And what we'll need to do as well here is we need to install ML.net, but I think we can just use IntelliSense to find that. So for example, what I want to do here is I want to create a private method here, iDataView, and load data. And what it's going to do here is going to create a ML context like we do in ML.net. We'll call it seed1, doesn't really matter. And then what we're going to do is return ML context data load from file. We're going to use a relative path here, so it's going to be data.productreviews.csv, and we're going to say has headers is true for this file, I think, and we're going to say separated char is going to be, in our case, comma separated char. And we need a schema for this, so I'm just going to copy the one we have, because that's going to be the fastest. So we can see here, model product review is like this, sentiment and review. So let's put that into our folder here as well. Call this product review. Oh, come on. Copy, please. Be nice. Be nice. Alright. Product review. We're gonna add attributes for ML.net. And we should be good. Okay, there we go, we should be good. So now we should be able to do this product review. And that should be able to give us data view. So if we do data, get our load data, that should give us our data that we need to pass in here. Look at that. And we'll just do await here. And what we want to do now is we want to look at the data here and see what we have saved. So we need to figure out a way to, we need a get method as well, because we need to fetch the data and understand how it looks like. But before we do that, I'm going to just run this test to see if we actually create those tables, if anything works at all here, before we start comparing those kind of stuff. So, let me think a bit. I know there's one thing we have to do. We have an issue open for that right now, but for now, what we'll do is just fix this. Right now, there's no way to migrate our database here. So I'm just going to drop it and recreate it. Before we run the test here. But there's an open issue for that right now, so if you want to start looking at just migrating automatically, then that would be great. Alright, so now we're going to run this test, and hopefully it will create our tables, and it will add the data for those tables there. That's kind of what I'm hoping. Hopefully it doesn't throw exceptions. Let's see. We should probably debug this honestly, because I feel like it probably won't work the first time. But who knows? Who knows? It's doing something. Let me at least put a breakpoint here and see if it works. This is taking a while, which is okay, it failed. Okay, file, okay, that's good. It's just an issue with our file path here. And I think we need to do that, and maybe it's just this slash here instead. Let's debug this time to make sure that this works. Okay, let's try that. I think it was the first slash that got it confused. Product reviews. That should be good. I believe in us. I believe in us. Okay. Come on. Are you running or not running? Should be running, but I don't see the test here. Okay, here we go. Let's see if this passes. Okay, good. So now we have the data. That's all good. So let's see what it does now. We should create a DB context. Why are you failing? And why it takes so much time to create a DB Oh, sorry. Okay. That's done. We need to rerun it again. But we need to remove this because I don't want to delete it every time. Definitely an issue to look at, for sure, because it's definitely an issue right now. We need to fix it. Alright, load data. Run ID, that's all good. Add it's fine. So let's look at the columns now. So now it's going to loop over my columns, and I should have two columns. One of them is going to be the sentiment, right? Sentiment and a boolean. Perfect. Look at that. That's exactly what I want. The second one should be called review and type string. And read-only memory. Okay, interesting. That's probably something they have. Let's see if we can figure out a better property for this. Because you can see that it wants to be a string here. Type, okay. Type, raw type. I don't want a raw type, I think. I do want the other implementation here instead. Where can I find that? Type here. I think it's just to string. Type will give me that one. The full name is not going to give it to me. I think toString is going to be fine. Okay, but regardless, if we just let it complete first here, sorry. That should at least completed that. Okay, so let's look at the database here. Let's open that up, and while we wait for that, I'm going to fix this. And I'm just gonna call toString here to see if we can get this proper name here next time. But it looks like it's working as expected, so that's really nice. But I want to check the database to make sure tables are created, and we'll wait for that to start. We need to be able to verify things are working, and we can do that by either creating a get data method to fetch the data based on a run ID, and I think that's what we're going to do, because I think usually that would be just easier than going to the data context here. So we can do that by going back into this one, and we will do public data get data, and it'll be run ID that we'll have to pass it for. And this is going to be a super small method, but super useful method. What it's going to do here is fetch the data for us. So we'll go in and say return db data. Well, actually, what we're going to do first here is fetch the data. I want to construct the object here for us. Data first or default, where run ID equals run ID, and if data is no, return no. We don't want to continue here at least, but then if we want the data schema, db get first. We're gonna have only one here, so that's good. Data ID equals data ID. And yeah, I know it's like weird right now because we are not really constructing it ourselves here. We can use Entity Framework instead, and we probably want to change that later. But we have like a NoSQL implementation that needs to be doing this as well, so that's why it's just simpler in general, if you're wondering. Okay, and then we'll do columns, data columns here, and that's going to be db data column, where schema ID, I think, equals db data ID. Alright, and to list for sure. And then we'll do return data. Okay, so this is gonna get our data. We'll have to get this into our interface as well. Perfect. Get our data. We'll get data related associated. And instead of data here, it's going to be iData, because we want to make sure we don't expose the internals here of each invitation. Perfect. And that means that we also need to go and change that in our store here to return that. And I think we also have to change some other stuff here in the data. So for example, we don't have that yet here. We don't have like a collection here, so we need to create a new property here. It's going to be called data schema. iData schema. Okay. I think we already have that on our internal property here. Just need to do that. Okay, perfect. And then if you go to iData schema, we need the columns here. So this is where we need like a list of iData column, data columns. All right, we're close now. Very close. Very close. Okay. Collection of related data columns. Okay, and I think we need to go and look at this one to understand that this is going to be an iData column. Okay, perfect. So now what we should be able to do is in our test here, we should be able to say, okay, good. Well, give me the data that we have stored. So get data for my run that I just created, right? That should be able to be fetched. And now we can just verify that things are working as expected here. So save data, column schema, right? Column count should be 2, because that's how many we have. And save data, data schema, row count. I don't know how many rows it should be, but we can just check that real quick here. It's not what I want to do. Let's go into... One second, let me find that real quick here. Let's go and look at the data. mlops.net, git. Let me find the data. It's going to be in the review predictor folder. Here we are. Okay, perfect. Review predictor, trainer, prod reviews. So here's the data coming up. We can see that this is the data we're looking at, and it should have this plus minus 1 here. So we have a lot of data here, but it should have 44,676 because we don't want a header. 44,678. 4,676, right? Or 6. Okay, that should be the count. So let's see if you can run this again and see if this is actually passing and working as expected. Hopefully. If it is, then this is a good template for other, of course, other storage providers as well. This is going to be not implemented here. And one more place. Yeah, I know. To list, it's going to be as data view columns. That's annoying, but that's fine. Let's make it a bit more readable. It's too much of one row here. I think we have one place. Yeah, this was a lot of boilerplate code today, honestly, but I feel like it was still useful, and I feel like we got a lot of things done in a way. A lot of code down here, and a great start on this specific area. We have a good structure, I feel like. Even though it's kind of convoluted a bit, I feel like it's going to be easy to build on top later, to add other features that we want here. So thank you for bearing with me at least. yeah, that's a good point. At least if nothing else, it's a good way to see the code structure we have here as well. It's very repetitive, so you know, it's like for each storage provider it's very similar because we implement those interfaces, and then perfect. We just make sure it fits for each storage provider. So now we have this, right? So we have 2, perfect, and row count here is 0. So this is why we do integration tests, right? Row count is not what we expect it to be. So why is that? I feel like it has something to do with our execution here. This is great. This is exactly why we do tests. So something in this method here, it's not working as expected. Get row count. Okay. So let me put this aside here real quick. You understand this? Because something is. I'm going to put a breakpoint here and debug this. We have something here that is not getting a row count. And I bet you it's because we haven't executed code to load the data at this point. But I thought it would be done by itself when we call this method. So I'm a little bit surprised. But that's okay. Okay. So we're here, get row counts, and it returns null. Okay, why is it returning null? Is it because we haven't executed this yet? What if we do data view, get row cursor first? We get some intelligence here. Columns needed. Can I do this to force it to come? I promise you if I do this, it's going to give me 99 rows later. Okay. If I do this now. Okay. This is interesting. So let's go into look at what this code is doing here. Get row count. I expected that to execute, and it's not executing. Returns number of rows if known. Okay, this is the issue, I think. Yeah, okay, so I think the reason why it's null is because it's not been executed yet, and it's not until we actually call the fit method we execute this code, and that of course is an issue. And I'm wondering if you can force execution on this one. I'm not really sure if you can that or not, because I would like to just force it. That is interesting. Alright, so we have a couple options here. We can either skip this for now, or we can make sure people only call this after the data itself. I feel there's a big chance that they will call this in the beginning of it, so I'm a little bit concerned about that. Is there a method here that we can call to force the count here? Preview should, but that's just the head. This is unfortunate, for sure. Okay, I think what we'll do here is add a comment here for this, because this is obviously something we have to think of, and continue later. So what I want to do right now is open a PR for work in progress here, so we can kind of view what's changed so far, and we'll go back to this in a later stream, I think, because this is something that we discuss a bit as well and continue doing. So this is issue 160. Let me show you how we're going to open this up here. So what we'll do is open a new branch for issue 160. Create branch. And it's possible we have to drop this, honestly, this row count for now. So we look at the initial revision here. What we've done today is cleaned up some code here. We added some not implemented exceptions for storage account in Azure, and the same thing for SQLite. But we've added entities for our implementation. We have added a general method to get and store the data. We've added data catalogs and some cleanup here. Okay, all good. Cool, awesome. You can use many different things for GitHub, Brett. I personally came from a TFS background some years ago, so I used everything with TFS and came to Git for the first time like 2-3 years ago. I really like this interface here. This is called Github Desktop, and it allows you to do everything like just through the UI. You can use like the command line as well if you wanted to, but it's just easier. So I will just call this initial revision. I'll commit to my branch here, which is same as the issue number, and I can then push it to GitHub. Cool. I push this here. It's going to push all my code up to the cloud. Okay, and then we can open a PR. So now we have the code here. It's going to trigger me to open a PR for my branch that I just created. And like that, we can just open a PR. I'm going to call this work in progress. VIP for work in progress. And we're going to say added ability to log the data dimensions for the data used to train a model. And we'll do fixes and then pound the issue number. And the reason we do this is because if we do this, GitHub is going to automatically close my issue when I close this PR and merge it. Okay, this is currently work. Okay. And what I'll do as well here is I'm going to say a couple of things here. Remaining work on this PR is to understand why row count comes back as null. Implement store methods in SQLite and Azure. Add additional integration and unit tests. So we get quite a bit of work still remaining here, and it's possible we'll continue doing that next stream, but at least we got a good start here, get quite a few things changed. You'll see here that we kick off our CI pipeline here directly, and we're going to run the unit test and the general package build here, in addition to our integration test against containers currently in GitHub. So yep, this is a good start. I'm going to assign myself to it, and also the issue itself here, so people know that I'm working on this, and that should be good. All right, thank you all for joining the stream today. I unfortunately have to call it quits today and go back to my real work and do some other work, but this has been really fun today. I really enjoyed hanging out with you all. Thank you for joining, and hopefully you got something out of this as well, even though it was a lot of boilerplate code. Yep, Saturday actually won't be on Saturday. It's July 4th this week in the US, on Saturday I guess. So I'm going away for the weekend, but I may potentially do a stream later this week to continue this work here. We'll see a little bit on how my week ends up, but it's likely that maybe on Wednesday or Thursday, or actually later today, I'll jump on another stream to continue this work. We'll see, but I'll keep you updated. If you follow me on Twitter, you will see me there. Otherwise, just stay tuned for notifications on Twitch, I guess. Cool. All right, have a great day, guys. Thank you for joining.